Good morning, ma'am. Today I am going to say experiment uh, 7, that is page replacement algorithm. And coming to page replacement algorithm, there are many algorithms, but we are using FIFO and LRU. FIFO means first in, first out, and LRU is least recently used. And uh, this is the seventh experiment. And coming to the main aim of the program is to write page replacement algorithm to FIFO and LRU. And in an operating system, the use of paging for memory management is dynamic, and page replacement algorithm are needed to decide which page needed to be replaced when new page comes in. And whenever a new page is referred and not present in memory, page fault occurs, and operating system replaces one of the existing pages with newly needed page. Different page replacement algorithms suggest different ways to decide which page to replace. And the target for all algorithms is to reduce number of page faults. And what is mean by a page fault? Page fault is a type of interrupt raised by the hardware when a running program accesses a memory page that is mapped into a virtual address space but not loaded in physical memory. And page replacement algorithms are techniques used for operating system decide which memory to swap out and which write to disk when a page of memory needs to be allocated. Paging happens whenever a page fault occurs and a free page cannot be used for allocation purpose, accounting to reason that pages are not available or the number of free pages is lower than required pages. And it is based on output completion. And FIFO is oldest page in main memory is the one which will be selected for replacement. Easy to implement, keep a list, replace pages from the tail and add new pages at the head. And similarly, least recently used algorithm page which has not been used for the longest time in main memory is the one which will be selected for replacement. Easy to implement, keep a list, replaces page by looking back into time. And coming to program, this is the packages, and this is the class. We are using FIFO as class name, and this is a public static void main. And we are initializing a process pages frames and page hit, and a buffered reader is used. And first we enter how many number of frames we need, and F is used for frames. And then we enter how many number of pages we are giving, that may be sequence of strings. And frames and pages are initialized. And first frame, if it is empty, frame is empty, then it will internally take output as -1 and then enter page number. And then coming to here, if flag is equal to page, then flag is false and page it will be increased. If then uh, we will give output as page hit and page faults. And coming to output, first we enter number of frames. I entered it as 3, and then enter number of pages 6. So enter page numbers. These are the sequence of strings. So in frame 1, it takes first 3 as input and remaining as empty. So it internally takes it as -1. And second frame it takes 2 as in second place. So in third 2 it is already there, so it won't here only it will replace that 2 with another 2. And then 4 it replaces here, and then 5 it replaces first place, and then 4 it already there, so it hits page hits will occur. So number of page hits is 2, because here 2 is here only it is replaced, and here 4 is here only it replaced, so it gives a page hit as 2. So coming to LRU, list recently used. So here we initialize process frames, indexes and flags, and first we enter how much page table size we need, and then we will enter which element should be there in page table, and then we will give a page frame size, so that it will produce an output by page, and in which frame which element is stored, and then how the elements are replaced by one element to another element. So it gives output as a number of page faults it will give output, and first we enter here how many page table size. I give it as 10, and we enter elements in page table. So how many frame size? 3. For page 1 it enters 1, and page 2 1 5, and page 3 1 already exists, so it won't take here, it replaces here itself, and then 2. So and then 2, and then 7, and then 1, and 5, and 1. So it gives output as number of page faults as 4, and this is the output, and this is the successful completion of this program. Thank you.